today are rates of change. So yesterday we talked about slope. Today we're going to be talking about rates of change. All right? Rates of change. All right, so a rate of change is the same thing as slope. So those two things are the same thing. All right, the difference is that when we talk about slope yesterday, slope was just kind of a generic term. A rate of change, this is slope when we have specific units of measure. All right, so when we actually have data, it's slope using data. And it's not a coincidence that it's called a rate of change, because these are rates. It's actually, we want it to be a unit rate. These are unit rates. All right, so let's talk about finding rate of change. So yesterday what we dealt with were from graphs and from two specific points. All right, what we want to do is now we're going to find a rate of change from data. And in this case, we're going to be using a table. All right, it's still M for slope. Remember, it doesn't change. And if you remember, slope, it's your vertical change over your horizontal change. From a graph, it's your rise over your run. So these are all formulas or what slope means, or rate of change. Or it's y2 minus y1 over x2 minus x1. These are all ways to find slope depending on what you've been given. All right, another way that we can change when we say vertical change and horizontal change, that triangle, that is a delta in the Greek alphabet, and that means change. That's what that means, that triangle. So it's the change in y over the change in x. That's another way that we can use this. This is kind of how we're going to be beating up a table. That's what I call beating up a table, is finding the pattern in the table. All right, so let's figure out what the heck I'm talking about. All right, so the following table shows the cost of using an internet cafe, for a given amount of time. All right, so what we want to do is we want to find the rate of change in cost with respect to time. So we want to find the rate of change of cost with respect to time. All right, so here is our table. So we have time. This is in hours, and then we have cost. All right, so for 2 hours, it costs $7. For 4 hours, it costs $6, and for $14. Sorry about that. 4 hours is $14. 6 hours is $21. All right, so our rate of change, R of C, remember, that's just slope, is equal to the change in Y over the change in X. So what I do on a table, I'm going to find my change in Y. I'm going to create 2 more columns in my table. And I'm going to find the change in X between each point. I'm going to find the change in Y between each point. We should have the individual slopes here, the difference, the slopes, the rate of change between the first and second, and the rate of change between the second and third. They should be the same. That's what we're hoping. All right, so I'm just going to do 14 minus 7. I'm doing my change in Y first, which is 7. I'm taking my second minus my first, and then my second minus my first again. So I'm just finding the change between consecutive points. All right, you could do your first minus your second. That would have been fine as long as you do the first minus the second for your x's as well. Make sure you go in the same direction. I did my second minus my first, so I'm going to continue that with my change in my x's. So I'm going to find my first slope. I'm going to say M1 is equal to, well, my change, and I just want to make sure they're both the same. This is kind of a double check to make sure that this table has the consistent rate of change for the whole table. All right, that it doesn't change. So my change in Y is 7. My change in X is 2. That's my first one. My change of Y is 7. My change in X is my 2. So they're exactly the same. Let's talk about what these mean. What was our Y information? So here, if I look at my slope, it's 7 over 2. All right, but what is my Y information being measured in here? Based on the table. Carmen? The Y information. It's dollars. What is my X information from this table? Rafaela? That's hours. So I have $7 for 2 hours. Just go sit somewhere. That's okay. Thank you, sweetie. I have $7 for 2 hours. I want this to be a unit rate. So we are going to change into a unit rate. Because I don't care what it is, how many it is for 2 hours. I want to know how much it is for 1 hour. That is our rate of change. So, what is 7 divided by 2? And remember, we're talking about money. So make sure you're writing that properly, talking about money. Go on outside. What is 7 divided by 2? Maya?
It's 3.5, so $62.
Yep, $3.50 per hour. That's what that means. So that's what our rate of change means. I've now found our slope, or our rate of change. All right, and we want to know the cost with respect to time. The cost with respect to how many hours. So cost per 1 hour. You guys cool with that? L. I could have, when you simplify it, I want them to be. So if this table, as we do more of these types of tables, if this table would be considered a linear table, all right, where the rate of change is consistent between every single set of consecutive points, yes, it will always be the same rate of change once you simplify it. So I could have given you, instead of 6 hours is $21, I could have given you 8 hours is $28, right? And so when you did that change in X and change in Y, your first one, your change in X would be 2, your change in Y would be 7. But on the second one, your change in X would be 4, and your change in Y would be 14. However, when I make my slope, or my rate of change, they both simplify to 7 over 2. Okay? So yes, hopefully, when we are trying to prove that there's a consistent rate of change for the table, we want them to be the same. If they're different, then we have to say there is no consistent rate of change for this table, is what we would find. Does that make sense? Yes.
So if that was like say 9 over 3, then you would write no consistent.
There's no consistent rate of change. Yeah. Okay, so I want you guys to do this one yourselves now, so we can practice some more of this. 1 second. So here's the problem I want you guys to do. So go ahead. Who's still working? Okay. Raphael, do you always wear glasses? They look nice on you. All right, so all of you should be creating 2 more columns. All right, and we do our, how many of you guys are doing your second minus your first? How many of you guys are doing your first minus your second? Okay, if you notice, if you do your first minus your second, you might get both of them are negative versus both of them are positive. You should still get the same answer no matter what, so pay attention to those signs. So if I do 3 minus 1.5 gives me 1.5. If I do 4.5 minus 3, I get 1.5, so that's cool. All right, if I do the other way, for my x's, I have 60 minus 30, which gives me 30. And I do 90 minus 60, which also gives me 30, so that's cool. All right, so I can see that my slope, because they're both exactly the same, I'm okay with you just writing one of them. So somebody write what my slope is based on my numbers. Giselle? Excellent. So I like that you're putting units on there because it helps us kind of see what the heck it means. And quite honestly, that doesn't have much meaning to me, does it? Like, I mean, we can be like, oh, okay, well, that makes sense, but turning it into a unit rate is going to make a lot more sense, isn't it? So what is that, Giselle, as a unit rate?
0.05 miles per minute.
Excellent. Oopsie. Miles per minute. How many of you guys are cool with finding rate of change? Can you guys see that it's the same thing as the slope? And Seamus, that was what I was talking about with regards to with specific information, we will go ahead and do that division. When it's generic, we're not going to. You guys cool with that? Okay. So let's talk about another way that we could be using slope. All right? So what I want you to do is we're going to talk about this, and they have examples like this. This is right from your homework, but they have something like this in your homework. So we want to find a coordinate point. Find a coordinate point when given the slope. Seems kind of weird to say that because we kind of need our points to find the slopes. All right, but let's see what the heck we're talking about. So let's say, here's an example. I want you to find the value of x so that the line that passes through the points 2, 3 and x, 9 has a slope of 3/2. All right, so this problem is why you always write your formula down. You always write your formula down when you're using a slope. No matter what formula you're using at any point in time, always write it down. Because I guarantee you, particularly in advanced class and particularly as things get harder in science, in math, whatever the case may be, they're not going to necessarily just give you the 2 easy points and find slope. They're going to find a way for you to use slope in a very non-linear, very different method. And so knowing the formula is going to be key. So I know the slope of my line. I'm dealing with coordinate points. So I have to remember slope is equal to y2 minus y1 over x2 minus x1. Now all you're going to do is I want you to substitute the values you know. So what things do I know from this formula? What things do I know? Seamus? I know my slope. There's my m. So I'm going to go ahead and put that in. 3/2 equals. Well, I have 2 coordinate points. I'm going to go ahead and write them as x1, y1 and x2, y2. I'm going to do the one that's missing as my x1, x2, y2, and the other one is my x1, y1. Only because when I put it in, I have y2 right here, and that's what I wanted. And I have x2 right here, which is what I'm looking for as the x. So I know those coordinate points. So put in the ones you know and leave the value of x for what you don't. So my y's, I have 9 minus 3 is equal to x minus 2. So what I have created is I've created a proportion. How do I solve all proportions? How do I solve all proportions, Ryan? Cross multiply. So I'm going to have 3 times the quantity of x minus 2 is equal to, well, I probably should simplify this first. So let me simplify that numerator first. So I have 3/2 is equal to 6 over x minus 2. And now I'm going to go ahead and do that cross multiplication. How many of you guys got x is equal to 6? Awesome. So our coordinate point then is 6, 9. You guys cool with that? Yeah. It was the original coordinate point. I just filled in that coordinate point. Yep, that's okay. You guys cool with that? All right, let me give you another one like that for you to practice on. So you have 24 through 32 even. I'll give you one of the odds. Okay. I'll give you this odd because this might help you with one of the other ones. They're kind of funky like this. All right. So I want you to find y when the coordinate points, let's say for the coordinate points and slope. For the coordinate points of -3 and then y plus 1 and then 0, 4 and then our slope is equal to 6. That one's a little funky, a little bit more challenging, but you guys are up for it. So go ahead and do this one, please. Morgan, as soon as they start coming, thanks for running. Always start with that formula and fill it in. It's going to make your life considerably easier. You always start with the formula. Thank you, sweetie. All right, check with some people. Check with people by you. Okay. Someone tell me what to do. So write my formula down and then do this. All right, Ashley, you're up. Excellent.
And then we go in and we get x is equal to 4 minus times y plus 1 over 0 minus negative 3. And then we get 6 is equal to 4 minus, and then add the 1 over, for the parentheses. So 1 times y plus 1 over 3, we add 0.
All right, so if I have 4, hang on a second, I'm going to do 4 plus a negative y plus a negative 1, right? Isn't that the distribute? Do I have to do the distributive property here? Does that make sense to you guys? Right? So over 3, which gives me 6 plus I'm sorry, 6 is equal to 4 plus a negative 1 plus a negative y, right?
I have 4 plus negative y plus 1. My one was positive.
Well, you can't have that positive. That can't be positive because this is subtracting everything in here, isn't it? Does that make sense to you guys? You guys, seriously, I need you listening. If I have this, if I have 4 minus y plus 1, I do agree with you that this is a 1 here. How many of you guys agree with that? Okay, so this is 4 plus a negative 1 times everything in here. Do you agree with that? Okay. I have to distribute multiplying by a negative 1 to everything in there. So this ends up being 4 plus a negative 1y plus a negative 1. You know what I mean? Okay. All right, so then when I do this, I get 6 is equal to 3 plus a negative y over 3. Does that make sense to you guys? Okay, so now that I have that, what do I do? Okay. Whoa, what?
Oh, for the denominator of 3, I multiply this right side by 3, so 3 cancel out.
Oh, you multiply both sides by 3 rather than doing cross multiplication. That's fine. No, you're good. I'm good with that because there's no denominator there. I'm good with that. Multiply both sides by 3. So I end up with 18 is equal to 3 plus a negative y, right?
Yeah.
Okay, that's cool.
And then you add a negative 3 to both sides.
Okay.
And then you get
15.
Yeah, is equal to negative 1y.
Excellent.
And then you divide both sides by.
And y equals a negative 15, right? Yeah, there you go. How many of you guys got that? All right, that was a little bit more challenging, right? Okay, the last thing I want you guys to do. Questions on that process. Can you see how important it is to write the formula down? Right, and fill it in? Okay, so now this is the last thing I want you guys to do. So we're kind of going back to the tables. I want you to determine if this table of values has a constant rate of change. If so, what is it? So when you're doing this, I do want you writing down the formula for slope. So slope equals change of y over change in x. I make you guys do that. I really want you to do that because it's giving you a focus. There's a lot of people who are going to do change in x over change in y because the change in x is on the left, the change in the y is on the right. And that's a big mistake. I don't want you guys making that mistake. So writing that formula down is going to help you remember, oh, that's right, it's change in y is the numerator, change in x is the denominator. All right, so someone tell me, what's my first slope between the first two sets of data? Natalie? 90 over 4. How about, Natalie, my second slope? Excellent. All right, so how many of you guys got those? All right, change them into unit rates. Remember, this is $90 for 4 hours. This is $45 for 2 hours. I'm pretty sure that you guys can see these are the same, but let's just make sure. All right, so I'm going to do 90 divided by 4, which gives me $22.50 per hour. If I do 45 divided by 2, that gives me the same thing, $22.50 per hour. So there is my constant rate of change. You guys cool with that? Okay. Tomorrow we're going to start looking at graphs of actual data, all right, and interpreting graphs with regards to rates of change. And then after that, we're diving into linear equations. Okay? Okie dokie.